Good morning. It's with great pleasure that I welcome you all to the first session of SPS ECHO, a series of webinars organized by the Signal Processing Society of the IEEE Student Chapter at University of Monaco. This program was made possible in partnership with the Signal Processing Society of the IEEE Sri Lanka Chapter. For the first session, we have arranged a topic that is of immediate importance to everyone present here: undergraduate studies and extracurricular activities, specifically the regarding workload management, useful skills to learn, and international and local competitions. We hope you make the best of this unique opportunity to hear valuable insight from an accomplished professional so that you can better navigate university life as an undergraduate. If you have any questions to raise to the speaker, don't hesitate to send them through the link that we will be posting shortly in the chat. There will be a brief Q&A session halfway through the speaker session and another following the conclusion of the speaker session. Without further delay, let me introduce today's speaker, Mr. Kithmin Wickremasinghe, sorry. He is an alumnus at University of Monaco, where he received his Bachelor's of Science in Biomedical Engineering in 2020. And he is currently a first-year master's student enrolled in the Masters of Applied Science in Electrical and Computer Engineering at the University of British Columbia. He was also a junior lecturer at the Department of Electronic and Telecommunication Engineering at University of Monaco. He has contributed numerous publications and has actively participated in research projects in his areas of interest, which include bioelectronics, biosensors, and neural machine interfaces, among many others. I would now like to cordially invite Mr. Kithmin Wickremasinghe to address the session.
Hi. You can hear me, right, Roshan?
Yes, you are.
Okay, great. Thank you very much for that introduction, and thank you very much for the SPS Society of Student 1 Chapter of University of Monaco for inviting me, and for Dr. Samira, one of my lecturers at the department, for organizing this with the students. Yeah, I think this is a great session, and I'm very happy to share my experiences with all of you. So I was told that we could do this in a very casual and very open way. So I want all of you to connect with me, reach out to me with your concerns, questions. I would really want to help in any way I can with any insights that I can give or my experience. And I want to be a supportive person for all of you. So don't be shy. I know most of you this current way that the Zoom events are happening, it's very shy to ask questions and things, but don't be like that. Try to get the maximum use out of me, and also keep in touch with me even after the session. Yeah, I guess where shall we get started? I know that there's an agenda as well, so hi, Oshan.
Hi, Mr. Kithmin. So first, we were thinking of hearing your ideas about workload management.
Okay, great. Workload
and then after that, there will be a brief Q&A session, and afterwards, the rest of the two topics.
Okay, great. So yeah, okay. And please make sure that you send in some questions regarding any question concerns you have. So right. Okay, great. Right. So in terms of workload management, I guess most of you are familiar with the structure of the ENTC as well as the University of Monaco workload, right? You have to complete, I think most of you have completed semester 1. If not, you have to complete the first semester select a department, and then you have to complete 7 semesters within the department and do a final year project and finally graduate. And also the internship is always also involved. So basically, like you getting through university life, completing your degree means completing all the course credit requirements, around 150 if I recall, and graduating from your university with that requirement, right? So that's basically the little workload that you have to manage. And so how I approached it, I'll give you some guidance on that one. At ENTC, like each semester you have to select a certain number of modules, and you have to make sure that you choose the right modules that suit your interests, and you have to do the required modules, and you have to take some extra modules, and somehow it's your responsibility to meet that requirement, right? So I recall during my undergrad back in 2016 onwards, I always consulted someone who is more experienced than me, basically someone from the senior batches usually, but you can also consult your lecturers about which subjects that you should choose, and what you would gain out of that, and why you should do it, and how even how the exams are structured, how much work you have to manage for each of those subjects. So those were the crucial things that I wanted to know about each subject, and I'd specifically recall having I would ask one of my seniors, can I please talk to you about this semester, how I can do this? And even my juniors, Ramit's batches below them, I have had these conversations with them, right? So the first step was always to figure out what the workload was that I was managing, and then make sure that I had an idea about what I was signing up for, right? Because something most people sort of tend to neglect is not having a good scope of what you're taking on. And I think during my grad studies, this is a very good point actually. Most of the this I don't know if others have others have experienced this, but most of the concepts that you build in your undergrad at Moratua, with workload management and all these things, maybe Dr. Chamita can also comment if you have ideas. I still use these techniques for my higher studies, right? So I finished two semesters here at UBC, and the successful techniques that I built with workload management in my grad studies, I can still apply in my undergrad studies. I can still apply them for my graduate studies. And in graduate studies, they say that so in maybe in semester 3, you guys have completed for those who have completed semester 3 around 10 subjects, right? Isn't that right? Semester 3 had around 10 subjects, right?
Yeah. Generally, in a one semester, probably you have to go for at least 9 to 10 subjects.
9 to 10, right? Yeah. So
at least in one semester. And also, Kithmin, there would be students from other universities as well. So I think it would be for them as well. Yeah.
Yes, right. Yeah, that's true. So I'm talking about the engineering concept field right here. So what I want to note was that when in my grad studies, I had to select 18 credits to complete within my 2 years. So I chose to pace it 2 semesters each. 3 subjects were 3 credits. And then in 2 semesters, I can complete 6 subjects, 18 credits. And they say that one graduate subject is worth 3 undergraduate subjects. Like the workload of 3 undergraduate subjects is equivalent to 1 graduate subject. So basically, I'm still like using the techniques that I used in workload management for like the harder semesters in my undergraduate to get successfully do the hard semesters in my graduate studies. That's like I was able to handle the workload of 3 subjects this term. So definitely the skills that I developed at my undergraduate was what helped me in that one, and I was like definitely sure that was the solid foundation for me. So that's a great tip I want to provide you guys with. Like if you want to be successful with workload management, start building the habits right now for like your future career paths and all those things, right? So in terms of workload management, so know what you're signing up for. So I chose 3 subjects. I understood what the subjects had in terms of like content, outline, and then even like the requirements, the grading requirements, assignments and things, you can know like what needs to be done. If you have to do MATLAB, Python assignments, if you have the skills to do those things. So I did subjects that had to do cadence simulations. I knew nothing about cadence, but I allowed myself the time to learn about those tools and softwares, and even the course actually provides the support, but like you have to have that time like allocated in order to do better, like achieve that performance that you want, right? Yeah, so like first plan, like get that plan of what you're doing, like what you're getting into, and that's where the seniors come in. They give the insights. I'll just like use some Sinhala terms in between. So they say like what make කරන්න පුළුවන් මේ විදිහට manage කරන්න, and like I had that conversation. I got the idea, and in terms of like everyone has different approaches. So like my approach was I always like go to the lectures and I try to get a sense of what the like the lecturer was working with, and then I usually don't depend a lot on like live lectures. I'm like most of like a study person, like book study person. So I collect lecture notes. I also like refer additional texts. I write down my own notes. Like I have books with my notes written down. Like I had when I was graduating, I had like a bookshelf, and I had around like the lowest what you should call the shelf of the bookshelf. It was like filled with university notes. Okay, so the stack would like, I think Ramit knows the reference. Hasindu is one of his colleagues, also had a similar stack, right? So I had like a similar amount of notes collected during my university studies. So I always like kept the right required amount of time to do the things the way I wanted to do that. Because once you like develop a technique for yourself that you know that you want to handle the workload with, and you have to make sure that you have the time management requirements assigned so that you can do it that way. Like some very like even yeah, in the very like last years, sometimes like you don't have enough time, and then even like there are subjects that maybe like you feel like you say like minimum කරලා ගොඩ දාගන්නවා කියලා, like you do the very least amount of work and still like manage because like it's still a workload, right? You don't have to invest like your entire semester and just get through the subjects. Like there are subjects like that, but we can't deny that. So you have to like balance those kinds of requirements as well. ultimately the goal is to get through each semester successfully and get the results that you want. So basically, yeah, I think pacing yourself and understanding the requirements and figuring out how, like, what your style is. Are you that person like who studies throughout the entire semester and gets things done, or there are like miracle people who do last minute and get everything done, like they can handle the all the workload at the very last minute, like day before the exam they'll take like 3 hours and jam everything and then get through that. There's no problem in doing that as well, like if that's your style and if you know how to do it, then seriously that I think those kinds of things you have to identify about yourself during university life, your university career, and you have to like perfect that for yourself, and then you have to apply it, and you have to get the maximum results out of it, and try to like perfect it as much as possible so that it helps you after your undergraduates as well, which is what I'm doing right now, and like I am sure that that works, and that's something that will benefit your entire life. Yeah, I think, yeah, that sort of covers my approach towards workload management. But there are like maybe more details you can go into. Maybe I'll answer them in questions. What was the next topic?
Thank you, Mr. Kithmin. Before we move on to the next topics, is there any questions that the members would like to ask? You can unmute and ask.
Please do ask questions. It's best to like do this as a question answer session as well.
Can you hear me?
Yeah. Hi,
so one of the questions I have is, so sometimes you have you just find an area that is just like out of the, you just have to go just out of the curriculum a bit, just to explore that area.
Yeah.
Like for example, I'm getting into digital design and processor design. So when you're doing that, it's kind of hard to manage that with the academic stuff, like the projects. So those things take much more time. Those projects.
So
how would you do that?
Right.
Manage that?
Definitely, like going outside of your like syllabus constraints is a really wonderful thing at times, because that's like you know, like the syllabus is like designed to give you a little taste of the subject, right? You can like never learn the pure essence of the subject sometimes from just doing the syllabus and doing the assignments. And if like you're passionate about some certain subjects, like you said, digital design, it's not enough for you to just do the content, do the bare minimum and just get through, because that's not going to benefit you on the long run. Okay. I give a small experience. So I took lasers. I didn't have the opportunity to learn about lasers during my undergrad. Here in UBC, you can do two undergraduate courses for requirements. So I did analog IC design and lasers. Analog IC design, I could relate my undergraduate knowledge and get through that. But for lasers, it was completely new, like new subject, starting with quantum physics and structure of materials and those things. And there was like the content, the slides were like not helpful at all. You don't have anything you can like gain from the slides. It's just like very brief information, so you have to do the extra reading. And I like went through around 5 books to like do that. And what I found like really helpful was the best way for you to like get the understanding about the subject was either teach it to someone else, so that like put yourself in a position that you want to teach it to someone else, and therefore you have to gain the extra knowledge. Like you have to fill in the gaps that you find in the subject, and you have to do the work. so that you ultimately have to teach it to that person. So like you have like a deadline or some like constraint on yourself, and even if you don't feel like you have the time, like you somehow manage, right? Because like deadlines are like hard coded in our engineering brain, like you have to meet them. So you like do the like you go through mountains and things, and you have somehow meet the deadlines. So I did something like that. I like tried to write my own articles on that subject, and like show those articles to my colleagues, and get them to read what I am writing. So that's one way you can approach it. And then since you mentioned like you like ultimately you don't have enough time in your semester to dig as deep as you want, and you find out like the books with like 700 pages written on the content, and you don't have the time to go through all of that. That's true. But so if it's a subject that you're uh, planning to study in the future, it's always good to know where you can get the knowledge from, right? So identifying this is the book for that, that's the book for that. So like even today I know that for signals and systems, Oppenheimer's book is the best book in the world, and I know where to go when I want that knowledge. But I don't remember like half of the signals and systems knowledge that Rangasa taught us, because I only know the things that I have like used again. Like retaining the knowledge is completely like different in terms of the situation. So maybe like I think the thing here is that you have to identify how, like you have to have like gain the skill to understand how far you have to go beyond the lecture notes, but also make sure that you don't like invest too much time, because you can always gain that knowledge at a later date, right? So it's so how I do it is I look at the lecture notes, I look at the subject syllabus constraint, and I always try to fill in the gaps that I don't understand using extra material, extra reading. But sometimes I constrain myself to the syllabus and maybe 1 or 2 extra lessons. And if I want extra knowledge, I do a project in that particular field, right? So if you want to do your FYP in digital design, definitely you will go beyond the syllabus. And if you think that, okay, this is the side for me, I should do higher studies, I should do a job in this area, you'll definitely become an expert in that field. But if you're becoming an expert in, I don't know, optical fibers, or maybe not optical fibers, robotics or something like that, maybe digital design is not extremely important for you in all the situations. So like that knowledge might it'll maybe stick with you for 1 or 2 years, but you'll ultimately forget everything. So in a way, me personally, I don't invest time a lot in things that I don't like plan to like keep with me for like the rest of my career, right? Because I don't think like I don't actually find that productive of the time that I'm investing, right? Is that a good answer for your question? Do you have like follow-ups? I can't hear you, Pavish.
Sorry. Yes,
Yeah.
yes, sir. Thank you. Thank you for the answer. Yeah, it was
Okay.
helpful.
Okay. Thank you for the question. Any other questions from anyone else?
So there's another question. Before that, a quick reminder that you can post. You can either unmute yourself and ask, or you can go to the link that's in the chat and post your questions there. So there's another question that's it's about sort of when you talk about workload management, some people prefer sort of this long-term approach where they plan, okay, for these 3 months, I'm going to start slow and then increase my pace little by little. And then when the exams come, very close to the exams, you increase your pace and all you do is study. But how does long-term planning in like this, how effective is that when the the situation is sort of unpredictable. Like, for example,
Mm.
you plan to study, you plan to work on your laptop tomorrow for like 5 hours, but there's a 5-hour power cut or something. So like, especially in these times when the situations are so unpredictable, how effective do you think is long-term planning like this?
Okay, yeah, that's a good question. Yeah, well, first of all, like I'm very sorry about like the situation that you guys are going through. So I'm sure it's definitely difficult, more difficult than what we had to go through. So like there's always the added hardship that you guys are overcoming. So definitely that it's a very strong thing that you guys are facing this obstacle and like getting over it. And like if you have specific questions related to that, please ask me. So I'll try to help with that. Yeah, thank you, Oshan, for that question. So yeah, so in terms of like losing the 5 hours that so there's this thing I heard when I was studying for A-levels. Like if you are a target oriented person, like you never let the time go to waste. That is if you're like losing 5 hours of your week due to some situation, then you have to somehow regain that 5 hours from some other situation. Like so I used to have a like small nap during the evening, but then I would like work 2 hours extra during the night to recover that time that I invested to like relax myself. And basically that always works. But and like once you perfect how you're doing that, you can apply that to you can apply that without even like planning for it ahead. Okay. The thing with the current situation is that because it's unpredictable for you to like make a long-term plan, and that's okay. You don't like necessarily have to depend on a long-term plan, like you're doing these things. But uh, uh, what I would recommend in this kind of a situation is do a target-oriented plan. One model I use is and in on each week, even in coming to graduate studies here, I don't have the luxury to use like my full scope of the time available for me for my studies. So I'm always like short-handed on the time I have, because you have to go to the university and do this. If like lecturer calls for like supervisor calls for a group meeting, you have to be at the group meeting. Then like you have to go meet friends, and you have to do those kinds of things. And like there's a lot of additional things that came in unexpected that you have to deal with. And so like you're not always investing time for your studies and projects, and even like getting in trouble with the supervisor because you're not balancing everything. So those things are still here in the undergraduate studies, graduate studies, still it's there. So what I do is the goal here is at the end of your semester, I don't know, university or this, at the end of particular term, you have to meet your targets. Okay, that's the goal. Whether you invested the last week or whether you invested the entire semester, you have to meet the goals. Okay, and all of you have different requirements in meeting that. Some of you actually might only want like a B or the very minimum grade for certain subjects. There were friends of mine who were like that, but some of you want to do your best. So the people who want to do their best have to allocate the right time requirement. But in the end, you list down, what I did was I list down the targets I have for the semester term. And then I also have like a running to-do list of things that I'm doing each week. Okay, so in that I'll actually show that. So yeah, like so this is one to-do list. I got this like it's actually says to-do list. Yeah, let me see that. I don't know. Yeah, so, yeah. So that's one of those, and this is my most recent one. I threw it in the garbage and then took it out because it had some stuff written that I haven't done. So yeah, so I have this running to-do list, and I'm always like keeping track of the things that I want to do and making sure like the deadlines are always there, and even like if the hell comes on earth, I'll still try to do my to-do list before the deadlines, and that's basically how I'm surviving graduate studies. But I think that technique always comes into play because in an unpredictable situation, like you can't assign මම මේකට මෙච්චර පැය ගාණක් දානවා මේකට මෙච්චර පැය ගාණක් දානවා. That doesn't, I don't know how that makes sense in an unpredictable situation, right? So you just keep note of everything you want to do, and each week you try to do certain things. Deadlines close ones you try to do that week. Further ones you see if you can put it to the next week, and then like do that. You cut off the ones that you have done and you move on to your next week's to-do list, and like you keep that running to-do list. And it's very exciting when like these things that you see that you're like working with, you see that like very senior people also doing so. One day when I was attending this conference, sorry, actually a lecture by Professor Saman Halgamuge from Australia, who was giving a lecture in the library at the UOM. So for that lecture, one of the senior professors from civil engineering came. The sir retired recently. The person who taught us statistical mechanics in structural mechanics in first semester. Does anyone remember the name? Professor. Anyways, he was a very respected senior professor, and sir, do you remember the name?
Is it Professor Priyandas though?
Yes, sir. Priyandas. So Professor Priyandas came, and I was sitting behind Professor Priyandas, and I saw that he's a very senior lecturer. So I saw that he was like listening to those things, and then he took out this small notebook from his top pocket, and he was writing like things down, and he was like he has cut little certain things down. So like very like 68 more than 70 years old senior professor still using like a very rudimentary technique that even I am using. That's a very like motivating thing, right? Like and then like you always like write down what you think of, and believe me, like this technique has helped me a lot, because you can't always keep track of all the things that you want to do. It's very hard. Like you like suddenly when you're in the bus you remember 10 things to do, and like when you're in the shower you remember how to do those things, and those kinds of like nice moments are there during your like engineering profile, like undergraduate career. So you have to always like write those things down, and you have to like always have this working list of things to do, and it's you can make it either time dependent or independent. Like some people are really good at making it time dependent, and some people just like make sure that the list is done. Yeah, so I recommend you guys like in this difficult situation to maybe like try a time independent system, because I understand like when the power cuts you have no chance of doing it, but if you have a running list of things that you want to do, and you know that these things need to be done, maybe you can fit those 5 hours with something else, right? And you can the end goal is always to get that done, cut it out of the list. So I hope like you can put that kind of a system in place. Hope that answers that question, Ishan.
Yes, thank you. That answered the question perfectly.
Okay.
Next, I think due to the time constraints, we would have to move on from the Q&A session. Next, I would like to invite Mr. Kithmin to present his ideas on his experience and his insight on local and international competitions, and also some of the useful skills that we could learn during our undergraduate studies.
Okay. So I think it was mentioned that there are other people from like other faculties here as well, but I'll just show you an example of what my skill profile looks like, and then the international exposure I tried to get during my undergrad. Yeah. Okay, so so I'll do both of those together. This is my website actually. So in my website, as a electronics engineering undergraduate, I tried to have a variety of skills that I could put on my profile that reflected what I'm interested in. Now, like you can see, like circuit design, 3D modeling, coding. I just put this to here because I used it for the website. And then Python, MATLAB, robotics, embedded systems, and some machine learning, and then this OpenSim for mechanical simulations. Yeah. This is like basically like a small professional like skill profile that would go on my CV, and then this thing I also have like a what do you call this soft skill profile as well. And both of those things are important to go on your CVs because actually this is a good point for you guys to understand. When it comes to employers hiring you, always know that your soft skills profile is more important than your technical skills profile. Okay, that like you need to be good in your technical skills, definitely, because you can't do engineering jobs if you don't have the technical skills. But if you want to be like a successful engineer, a very like very strong engineer leader, then you have to have a better soft skills profile than your technical skills profile, because technical skills will keep you in your comfort zone as long as you want, but soft skills is what you can will boost you ahead, like push you forward in life. And this definitely applies in foreign countries, maybe more than Sri Lanka, because they say that here, I heard this because I went to a what do you call that hiring session, like employment thing, like a session that was here, and they said that companies would rather hire a person with like good soft skills and okay technical skills, because once they hire that person, they can always train that person in the technical skills. But if that person, like, they know that he's a good person with leadership, trustworthiness, and good communication skills, ability to like deal with different situations and all those things, then definitely if he's good enough to gain the technical knowledge, definitely you'll get the job, because that's like the hiring policy of these today's like companies. And you hear that a lot once you come out of Sri Lanka, and maybe even in Sri Lanka you can see that situation is there. So yeah, and then yeah, so that's my skill profile. And I guess what I want to mention is that try to you're anyways getting some of these skills like MATLAB, Python. Engineering graduate anyways gets those skills throughout the course syllabus, and try to get like studying ROS was something that I did extra, because that was not part of the syllabus. Even in the internship, I didn't get to use ROS much, but I studied it for my own purposes and to do projects in that, and that came in helpful. STM32 embedded systems I use for my, it wasn't actually taught to us during undergrad, but I still did projects with it, and I successfully used it for my final year project. So based on your requirements, choose the skills that you're going to learn, and make sure that those skills will benefit your career as well. Like machine learning, I think all of you agree that it's definitely a worth to have skill as like today's engineering students, right? Most of you are electronics engineering students, and even in other fields, machine learning, coding, definitely valuable skills in today's job market, and well as basic undergraduate situations. Yeah, and I'll show you about like the exposure I got from international and local competitions. So I was a very project-oriented person because I think coming to one of the questions that was asked, I think yeah, Kavish's question. So I learned so much more from questions projects than I did from my courses, because like in projects you have to deal with the actual situation, and you have to like dive down like really deep into the problem and understand it properly, right? And I honestly think that's more important than just being familiar with the subjects, because engineers have to apply things in the real world, and like real world, like dealing with the real world problems means facing those things. Elon Musk has this interview where he says how he hires people, and in that he says that he always like goes for the people who have like evidence. Like when he like does an interview, he talks to the person and asks him like what he knows about this particular job, and then the problem that he's going to deal with, and like he makes sure that the person is well like really in depth with the problem that he's dealing with. And the people like PhD graduates and people who have really invested their time in this problem know that problem to the very core. That's why doing like the PhD, like that's the whole focus of doing a PhD. And like my robotics projects, like we started from very basic robotics under Dr. Peshal, and we evolved up. Like we didn't win competitions or anything. We just built failing robots, and then at one point we finally won our first competition with a successful robot, and it was like very tiring and very lot of invested time and hard work just to come to this point. And from this point onwards, we went for an international competition, and we kept developing our robotic skills. And then by the time we were in the final year, we had developed this one's actually done by me, this was done by my colleagues, but all of we all went through the same experience. So we developed these kinds of four-legged robots, and then this thing that pneumatics and very beautiful systems. I expanded my so this was a completely random project. It didn't have anything to do with university or even like competitions or anything. I just did it out of my own interest. I just took some time in August 2019. I ordered some parts around like $100 I invested, and I just built this little thing. And even up to today, I show this off to my friends here in Canada, and everyone's like super impressed. Like I can like tell people like I've done this kind of thing, and everyone's like wants to know how I did it and all those things. Maybe this also helped me get into graduate studies because I had this kind of exposure, and my supervisor was also like impressed about it. Yeah, I think this is my 2017, right? So very old for things. And then so this was a very interesting one. I think you have heard of battle robots. So our first robot was this one. It failed. Second one also failed. So first year wasted, second year wasted, third year we won, and we beat like the three times in a row reigning champions. And we won that one. Like we smashed their robot completely upside down, and like people were like shocked to see that. So like those were very nice experiences. So that's how I deal with that. And then once I finished my undergraduates, I focus a lot on like how we like Sri Lankan students can go for like graduate low international competition. So we went for like these kinds of competitions, and this one actually we won. We designed a project for during the COVID-19 pandemic, and we won this special to design student design competition. Okay. Yeah, and I think Ramit was we were first runners up, sorry, and Ramit was also part of this one. So it was a very nice experience, and like during this experience, we understood that our ideas, like the ideas that you guys have as undergraduate students, is very valuable. Like the ideas that you develop at your universities, your departments, and the ones you work with your supervisors like Dr. Chamita are very valuable, and they have a lot of recognition. The way you guys think and you approach problems and you deal with it. And if you ask any even like graduate students in countries here in the West or in Australia or anywhere, and even like certain professors who visit Sri Lanka and like look at our work, they're very impressed with what we're doing in the like very resource constrained in situations even. And I always like encourage students to like give their value to their ideas, because you have that international the level of thinking that can go international. It's just a matter of getting that project done and with the right guidance. And definitely like if you have your motivation intact and your dedication, you'll definitely get these kinds of achievements, because these are like very manageable things for you, all of you. So that's the message I have to give there. Yeah, so I did a lot of projects. I invested time in projects, and by the final year I started investing time in like research based projects, and I wanted to get publications at like top conferences. I'm on my most of you already know and have experience with this, but that was sort of the approach I had with this. So like start with basics, very simple things that will definitely fail. Maybe lucky, like if you're lucky it will succeed, but start doing things, like start experimenting, go get your way developed, enter competitions, know know your level, like know where you are at and what it takes to win something, then improve that one to go international, and try to compete in the international scenario. And once you are like satisfied with the level that you are at, then start looking at research based projects, and try to implement what you have gained and what you have gathered and learned into like solving new problems, not existing problems that you're given. Try to find something that no one has ever solved and try to solve that. It's very tricky when it comes to doing this particular thing, but if you like give it enough time, you'll definitely find like what you're looking for like you'll find the right problem that you're looking for if you like give it enough time. This is also a very nice story that happened to me this term in my studies. So I started the semester I wanted to work on optimization problem. Okay, so I have like, so I'm in analog IC design, but electronic circuit design. So I have experience with machine learning, you guys saw. So I did a internship in Japan in machine learning or AI, and I have that experience. So I wanted to see if I can combine analog IC design and this machine learning field. And when I like went through paper, if I tried to find this new topic I could new problem I could solve. My lecturer wanted to support me as well, and when I looked at most of the literature, I found that like people have started to solve these problems, and if you look at like the most uh, uh, unsolved problems, they were like really complex, and I felt like maybe I can't manage to do that. But as like I didn't give up on this one, so I then like had discussions with my supervisor. First month I didn't do anything. Second month, that's like February also, I found some new ideas but didn't do anything. Third month, I proposed to the supervisor I'll do something that someone else has done for my final project. So I successfully did a final project and understood what has been done. And then in the fourth month, that is like last month, I sort of came across quantum computing. Okay, so I was thinking like why don't I like try learning quantum computing? And quantum computing has optimization called quantum annealing, and it's a very like beautiful technique to like do day-to-day optimization problems that you do with like traditional algorithms using quantum algorithms. So and like yesterday or day before yesterday, I had another meeting with my professor like after 5 months, and I asked him like, can we like do this? Can we be the first people to solve a analog circuit design problem using quantum computing? And definitely like supervisors, oh my god, yes, that's what we have to do. And they're like, they automatically generated a new problem that we could work on. No one has ever attempted to solve. So and that's what I'm focusing on. And definitely like it's like very motivating. It took a long time to get there, but very motivating to work on it now because no one has done it. You're very motivated to do it, and it's very new, very exciting as well. Yeah, so like keep that commitment and like a target about what you want to achieve out of it, and do this. So here's another thing. So this was a project I did in 2018 December. Just idea I got. Like I was a biomedical engineer. I was thinking like as a biomedical engineer, I need to learn. I need to at least be capable of doing like a bionic arm. Otherwise, like it's very how do you say, like it's very shameful of me to call myself a biomedical engineer. And so I built this arm in 2018, and I built a circuit to get like EMG signals from my muscle signals from my arm, and I wanted to interface it into this arm to control it. Okay, so this project just happened from this to this time, and I thought like that's the end of the project, right? But it ended up, this project was expanded into our FIP, and we did it under the supervision of a professor from Denmark, visiting professor, and he was very experienced with this field as well. And that project became this one. Like we never expected that to happen, but finally, like we built the improved circuits using flexible PCBs, bendable PCBs, and I built like very compressed. I can show you this image. I built very complex and very compressed, very small circuits. This one with microcontrollers, and this entire system was designed to control this model simulated arm and then the actual arm. So this was my final year project, and you can see how that stemmed up out of this, and even the skills that I gained from this project went into this project. See, so there's a huge connection between everything, and like none of the things that you invested your time into just like becomes a waste. It always comes back and rewards you. And I even like not just me, Ramit and many people here have similar experiences with their undergraduate project experiences and how that has rewarded them. Yeah, it took a lot of time, and but I think I covered what was required for that topic as well, right? Hope that.
Yes, thank you, Mr. Kithmin. That was very informative. But
Yeah.
I think there are some received questions that we have.
Yeah,
if
no worries.
I know the answer. First, so looking through the last few bits of the session, there seems to be a big emphasis on sort of like having a flexibility to like constantly be learning new skills, so that as I think from the projects, it was evident that they were like very diverse. And so is there any approach that you take when learning a sort of a new concept or a new skill, or in your academic career or anything else?
Okay, yeah, thank you. That was a good question. So yeah, I think in terms of so I'm trying to learn particular skill these days. If I can share that. So always, I guess the most important two approaches that I'm taking, I'll share this. So I would need to learn this tool called Comsol Multiphysics. So I'll put this into my website now. That once I learn this, that I know this. And Comsol is like very powerful tool for modeling and simulation, and in like these are industry recognized tools. So it's very important that you, when you're learning skills, to learn things that are very relevant to your career and very like recognized. So if you are familiar with certain industry renowned, like if you know certain things that make you shine compared to others, like if you're expert in certain things that very few people are experts in, that gives you a very competitive edge when you're asking for a job. Like they don't even have to interview you, like okay, you know this, just come and work for me, please. That's how it happens. So Comsol is one of those tools, because very few people know exactly how to apply it for different situations. And I'm using this for my studies, so my project, so I'm trying to learn it. So this is where I'm starting. I'm starting with some introduction document and a very basic place. So maybe like if in like coding terms, it's like a hello world situation that I'm going through still. But maybe this is not like enough to motivate you, right? So the additional thing that I am trying to do here is I'll show that as well. So okay, maybe I'll just share this. So I've like searched online, and I found online courses of these particular tools, so that I can learn from others. And this is a very important thing all of you have to understand. When you're learning something on your own, you have to invest a lot of time for the learning curve. It takes a lot of time for you to understand it exactly for your requirements and apply it and all those things. But if you're being taught by someone, that's the entire concept of lecturing as well. Why lecturers invest time to teach you, because they know what needs to be taught, and they are there to answer your questions. So basically it reduces the learning curve that you have to work with, and lets you like approach the final objective faster. This is what I'm doing with this one. So I found this course, Learning Comsol Basics to Advanced, very valuable for what I'm doing, and it has like this 10-step approach to understanding this tool, and it's perfect, right? So I'll just go through this course and understand what he's trying to teach. There'll be gaps, but essentially I'll be able to get like a basic understanding of everything I need. Maybe even for an interview, if you need to show that you have a certain skill, just do a course and be familiar with it, and maybe even it'll work out. I'm pretty sure it'll work out. Sometimes the courses are not free, but I think it's about doing the right investment to gain the right knowledge, because like even I'm not sure if so like something there's a Comsol website. Okay, so if you go here, sometimes you will see that certain courses are worth courses. Okay, courses. And if you go to this one, so this course, this is a 4-day course. Maybe it will take you maybe a month to learn, but this course is worth $800. That's how much is that now? So that's like a very expensive, right, for a little knowledge, but that's how much like knowledge is worth when it comes to this situation. So like if you ever ask like in interview, and then you can show that you know this thing, like you have like in the $800 worth of knowledge with you, and if you can like understand the value of the skills you're gaining, and the value the industry gives to that skills, that's a very great thing to have. Definitely. I think these are the two basic approaches I'm using, and I use EDX a lot, you can see. So I use EDX for doing these kinds of things. I can show you what my EDX looks like. Yeah, machine learning, AI, microfabrication, silicon photonics. Yeah. So I have like since 2018, I have EDX certificates, and you can go to my LinkedIn and see I've all like listed down all the things that I've done, and like gaining a certificate is motivating for doing a course. So that's also one of the advantages. Yeah, I think that's pretty much my answer to that question.
Thank you. And as a follow-up question, for this self-learning process, what is the substitute for examinations? How do you test the information that you are well versed in the information?
I think you have to do a in substitute for examinations. You have to do a project successfully in using that tool, and you have to like demonstrate results, like acceptable results that you gain from that tool, and get someone to verify that you have done it correctly. So best way to learn certain tools is have a like a final objective that relates with the work you're doing, such as like if you're want to do it for learning the tool for research projects, you have to have like once you finish learning the tool and you apply the tool for your requirement, and get the results that someone else will verify and affirm that you have done it right. That's one of the best ways, I believe, to approach this. So I'm even using Comsol for my project. I chose Comsol and I gave reasons why I'm choosing Comsol, and I have to do my project and I have to convince my supervisor that I did it right. And he'll ask me like very hard questions, and I'll probably like be speechless at first, but then I'll keep learning and learning, and I'll try to fill my gaps, and I'll be able to like know that I did it right. Okay, yeah, that's pretty much how I handle it.
Thank you, Mr. Kithmin. I think because due to the time constraints, we have time for one more question. Limalka, would you like to raise a question?
Yeah, Kithmin, can you hear me?
I can hear you.
Yeah. Yeah, as undergraduates, like we do things related to so many areas, but like I feel like we should like focus one area and master that. Like what I want to ask is how to find out passion. So we can pursue. Yeah.
Okay.
Fine.
Great question. Very hard question. Yeah. Okay, so for like only on like the undergraduates here, finding passion is unless you're like really lucky and you stumble it on it like in the first or second semester, which happened to some of my friends. Maybe Ramit is one of those lucky people. I had a friend called Kanchana. He's still he started in second semester. He's still in that field. Those are the lucky guys. But finding passion is very hard. Okay, I'm chasing quantum computing now, thinking that's the passion. Probably hit a wall, and then I like I don't know what will happen. But always there was this nice session by the Dr. Yasantha Rajakaruna, right, from USA. How we like switched from thing to thing to thing and tried different things. I don't think like there's like you can there's something called like finding your exact passion, but it's about always trying to trying to follow your passion, right? It's always like trying to follow your passion, and in doing that, I think what like you have to understand is it's okay to change your passion, but find something that interests you in university, and even if it's multiple things, that's fine, because circuit design, robotics, machine learning, signal processing, telecommunication, mathematics also is there in university, and other areas that I haven't studied. So all these things you'll feel like I have to do. I need a little bit of that. I need to do a little bit of that. So it's sometimes hard for you to choose exactly this. Maybe you will do robotics in your first few years, and you'll then see whether you can go ahead in robotics. Maybe that won't happen. Then you'll switch to like machine learning, and you get good at machine learning, and you try that out, and then you figure out that that's even not the right thing. And this happens even to the like best people. I have had conversations with undergraduates like you, very bright people. I don't want to mention names, but and even they don't like they don't think like they are cut out for this particular thing. So it's not about how good you are, how talented you are. It's like whether like you get that field and you understand what it allows you to do, what it adds to you, right? And the very like funny thing is when you like maybe like where you do some career change, or you go for higher studies, right? Then it will like run like 360 around. Like I had done robotics, electronics, and a little bit of signal processing, and I thought maybe I'll get all those things packaged and follow my undergraduate in that one. But I came here and I fell into analog circuit design and silicon photonics. I had like didn't even touch any of those. I didn't even do telecommunication. Some of you are doing telecommunication. I didn't know anything. And then thanks to God, I found Dhruvan sir's lectures and notes, and started studying everything. And basically, I found that I maybe might even have a knack for these things, and then like you figure out that you can get some experiences from undergrad and those things, and then fuel this thing. And once like you are comfortable with this, then you find something else called quantum computing, and you'll okay, this is the one, and like you're going through that. So I don't think like you have to stick to one particular. This is my opinion, but there are people who have figured out their field. But I think from like taking as examples like Dr. Asantha, I think it's always good to have an open mind about choosing your passion, because we live in like a very technologically advanced world. Everything's changing so fast, and the people who stay at the forefront are the people who are good at what they do. Like the people who are like very unique, right? So if I, for example, if I become the first person to do like analog circuit design using quantum computing, I'll be that guy, right? So try to be that person. Like that's what Dr. Asantha's philosophy was. Try to be that person who's like who's trying this thing, and who's like at the forefront of this thing, so that like everyone wants to have you, everyone wants to hire you. Okay, so I think that's a very great way for engineers to approach passion. Passion has to serve a purpose. Like it has to give you a career, it has to give you like the motivation to work and those things. So try to like align your passion with something that you're motivated about, and something that gives something back to you as well. Yeah, I think that's how I look at that.
Yeah, thank you, Kithmin. Thank you for your input.
And with that, I think we have to end the Q&A session due to time constraints. Thank you, Mr. Kithmin, for taking your time to share your valuable insight and experience with us. I'm sure the session was very productive for all of us present. Next, I would like to invite Dr. Chamira Edulsurya to deliver his comments on the session.
Yeah, thank you very much, Prashant. And yeah, Kithmin is not a new face to me. Actually, I have worked with him for several years, yeah, very successfully. And yeah, actually, I'm glad to have that the Signal Processing Student Branch Chapter at the University of Mara to organize a session like this. And also, I would like to thank Kithmin for sharing his knowledge as well as experience with our young undergraduates, so that they could succeed in their undergraduate life. So the other thing I would like to mention is that I agree most of the things you have mentioned, and also I recalled my memory when I was a graduate student. When you said the 3 undergrad courses are equal to 1 grad course, right? It was the same for me as well. I had to take also 3 courses, and basically in the semester 5 I took 11 modules, but the 11 courses in undergraduates, but I have to work more than the effort I put for the 11 modules to actually get the work for the actually 3 modules in the graduate studies. So, and that's a very nice and the experience in way. So, and the other things you have mentioned about the international competitions, how to find a fashion, and so all of these things are really valuable. I would like to thank again for allocating time and the agree to sharing your knowledge with these young undergraduate students. And also I would like to thank the executive committee and all the members of the Signal Processing Society Student Branch Chapter at the University of Maratua for this wonderful event. And also we plan to have several such events with similar alumni from the our department. And so I hope that all the participants would remain with us, and I believe that this event was a very successful one, and also all the participants got a very good knowledge on the basically the workload balance and the extracurricular, and basically the how participate for the international competitions and like that. So since the time is moving fast, I'm not going to talk very much, and thank you all again, and have a good night.
Thank you, sir. Just a small comment. So anyone like who wants to chat with me further or get comments or advice that I can help with, please connect to me on LinkedIn, or even if you want to chat with me on WhatsApp, you can get my number from any seniors. Please connect with me, and I'll be happy to help any of you who's requiring help. Thank you very much for attending as well. Thank you, and for the organizing committee as well.
Thank you. And before we conclude today's proceedings, I would like to invite Kavisha to deliver the vote of thanks.
Can you hear me?
Sorry?
Can you hear me?
Yeah, you're audible.
Thank you, Oshan. Good evening, everyone. Today we had a session on managing academic work by Mr. Kithmin Wickremasinghe. Thank you, Mr. Kithmin, for your time and giving advice to us. Thank you to our technical sponsor, IEEE Signal Processing Society Sri Lanka chapter, for providing support. And thank you. Give me a second. So there's some issue. Thank you, Dr. Chamir, for our student chapter advisor, for giving us advice in organizing the event. Thank you, Mr. Limarka Sadit, Mr. Ashen Duranjana, and Mr. Tusan Chamika, and the team for organizing and marketing this event. It was a really successful today. Thank you everyone for participating. We hope to have more sessions in the future and hope to see you in those sessions as well. Good night, everyone, and take care. Over to you, Shan.
Thank you, Kavisha. And that brings an end to today's session of SPS Echo. We hope you utilize this knowledge and guidance you obtained through this program for your path ahead as an undergraduate. Stay tuned for the following sessions of SPS Echo. Until then, stay safe and have a wonderful evening.